Okay, so the next few examples are, again, just building on this connection between radians and degrees that we know about and how we can use those effectively. So, example 3 is just a bit of plugging it in your calculator, basically. Find sine of 0.3 radians. Well, if I just type in sine of 0.3 and hit equals, I have a slight problem because 0.3 is not radians, 0.3 is degrees, so this is entirely the wrong answer. So if we think back to the little trick we used when converting on the calculator, I can do this by typing in sine of 0.3 and then use options and then 2 for angle units and then 2 for radians. And now it says sine of 0.3 radians and it will give us the correct answer. So for A, it is 0.2955 and then so on. If you would prefer to do that without having to put this little r in every single time, you can also do it by changing the whole calculator into radians mode. So pressing shift and then for setup, go to angle unit, and then we need to change it to radians. And now, because the whole calculator is in radians, when you give it sine of 0.3, it knows that this must be in radians because that's the setup. So it tells you straight away. So this is quicker if you're doing lots of calculations in radians. And then moving on, cosine of pi radians is -1, and tan of 2 radians is -2.185. Now, there's absolutely nothing complicated about that. Really, this is just making sure that you're getting the right numbers on your calculator. So it's probably worth just doing that example yourself on your calculator to confirm that it's in the right mode and giving you the right numbers. There's nothing hard about it. Second thing, example 4, sketch the graph of y equals sine x. So first things first, we're going between 0 and 2 pi. So we're starting at 0, which is nice. And then we're remembering that 2 pi is a full revolution. So 2 pi is equivalent to 360 in terms of the height of the graph, because 2 pi radians is 360 degrees. Now, where does sine start? Does it start at 0 or does it start at 1? We just need to check that. And then we need to put in our key points. If 2 pi is the end of that kind of repeat of the sine graph, pi is right in the middle, and we also kind of care about what in degrees would be 90 and 270, but in radians would be pi over 2 and 3 pi over 2, or pi and 1.5 pi, half pi and 1.5 pi. Okay, so we care about all those points, and we just need to sketch the graph in. So the sine graph begins down here at 0, it loops up to 1, it comes back down to 0, it loops down to -1 and up again to 0. I should put -1 and 1 in, and then I should attempt to sketch that fairly carefully. There we go. And we're finished. There's nothing hard about that at all. You just need to make sure that you're connecting those key points you know in degrees into those key points we now know in radians. Pi, pi on 2, 3 pi on 2, and 2 pi. Example 5, sketch the graph of y equals cos x for x, cos of x plus pi. So again, we're going to begin with 0 up to 2 pi, because that's the range of our graph. And we're also going to, again, care about pi, pi on 2, and 3 pi on 2. Those are going to be our key points. But this time, I want to just pay attention to the fact that we've got a transformation here of plus pi. Now, a transformation inside my function is a shift to the left or the right. It's a translation in the x direction. And it does the opposite of what we think. So adding pi actually means we're going to move the whole thing to the left by pi. And the way we dealt with these before is we sketched the original cos graph, and then we kind of looked at that and did the translating. So cos is going to kick off up here, and it's going to come down, and then down to -1, and up again, and up again. So I'm going to grab this and sketch it. But it's moved, or it needs to move, to the left by pi units. So this point's going to disappear off to, well, it's outside of our grid, never mind. This point is going to move across by, that's half pi, so pi units. Oh, that's gone off our grid too. This guy has going to move. Oh, okay, now he's on my grid, right. So we're here. Okay, so that's my first point. And then this 0 is going to move back pi. That's going to be there. So I'm coming up. And this one, it's at 2 pi, so it's going to be at pi now. So I can begin this sketch now because I know that it'll look like that. And I also know that the whole thing just carries on and repeats. So it's got to come back down again. It's got to do that. So this is cos of x plus pi. And you'll notice that it is just a reflection of cos of x. And that's something we'll talk about in just a minute.